Good morning, dear students. In the previous class, we have derived equations of motion for a particle moving in a plane or moving in two dimension. Okay. See, now let us consider relative velocity here. Suppose if you have a particle moving in a plane, see, then there are two particles are moving. A, say this is moving with a velocity VA, and this is moving with a velocity VB. So there are two particles moving with different velocities. See, then just like in motion in a straight line, we define relative velocity of A with respect to B as VA minus VB. See how this is actually defined. See, this is being defined by considering the velocity or the position vector with respect to the origin. Okay. See, by considering position vector with respect to origin, we find out what is the displacement produced. See, for example, if you take RA is the position vector of the particle A. See, this is represented by, if you some position vector, see RA. See, this is nothing but OA. OA is given by RA. And this is nothing but x1 into I cap plus x2 into j cap. Have you got my point? And say I take the position vector of B as RB, and this is represented by OB is equal to RB. Say this is x2 into I cap. If I indicate the coordinates by x1 y2, so this is y1, x2 into I cap plus y2 into j cap. Then what is the displacement produced? The displacement of the particle say during the motion is being calculated, and using the displacement we are going to calculate the velocity, right? See, just like in our previous derivation, I have showed that how we can determine the velocity. See, basically we consider motion of a particle in two dimensions by considering x and y coordinate. See, then when there is a displacement, we identify the displacement vector and calculate its value, and knowing change in dimension, change in the displacement, see, rate of change of displacement is considered, you will get the velocity. So we find out what is the velocity of particle A and then particle B. When you take the difference, you will get the relative velocity. Similarly, if you take a relative velocity of B with respect to A, it is given by VB by VB minus VA. VB minus VA. Velocity of B minus velocity of A. Have you got it? While making the calculation, we consider only the magnitude. Okay. See, this refers to only magnitude. See, later we indicate the direction. Have you got it? Suppose if the two particles are moving in the opposite direction, in such a case, VB minus of minus VA, right? See, this particle VB is moving along positive x direction, and particle A is moving in negative x direction. In such a case, VBA is given by VB minus of minus VA. See, this gives you VB plus VA. The concept of relative velocity plays a very, very important role in considering so many situations. For example, when you consider motion of a boat in a river, river is also flowing with certain velocity. boat is also having certain velocity, then we have to consider relative velocity of boat with respect to the river. Suppose if the boat is moving in the opposite direction, if it is in upstream, it is moving in upstream, then both the velocities gets added up. If it is in a downstream, then the difference will be taken. See, we will come to that situation later. Therefore, the concept of relative velocity plays a very, very important role in considering different situations of motion. Now we shall solve few problems related to our previous discussion so that you can understand this topic in much better way. A person moves 30 meter north, then 20 meter east, and finally 30 root 2 meter southwest direction. What is the displacement from the original position? What is the displacement from the original position? See here, let us take the situation. A person, see he is starting from, let us say he is starting from the origin. Say he moves 30 meter northwards, he moves along the north direction, north, south, east, west, and he moves 30 meter, 1, 2, I just take it as OA. Okay, this is S1. See, he covered 30 meter. S1 is equal to 30 meter. Then moves 20 meter east, 20 meter east, S2, 20 meter. Afterwards, finally 30 root 2 meter southwest direction, southwest, he moves like this, and this is S3. S3 is 30 root 2 C. So what is the displacement from original position? You have to find out what is the displacement. Displacement is nothing but the distance between initial and final position. Okay, that you have to find out. See here, you know that displacement is a vector quantity and it is resolved into two components, horizontal as well as vertical components. So let me take S3 is equal to minus 30 into root 2 cos. So why minus sign? Because I am taking here the component of S3 along this direction. See, this angle is 45 degree. See here, I cap, minus I cap, S3 into cos 45. See here, when you resolve it, S3 into sin 45. See here, there will be j cap, minus j cap. Therefore, I have taken minus sign outside. cos 45 degree into I cap plus sin 45 degree into j cap. See, this is actually S3. I take minus sign. Actually, see, this will be vector S3 is equal to, its value is 30 root 2. This is minus I cap, this is minus j cap. Therefore, totally you are going to get minus 30 root 2. What is cos 45? 1 by root 2 into I cap plus 1 by root 2 into j cap. You please take out root 2 outside. You are going to get minus 30 I cap plus j cap. This is S3. They ask you to find out what is the value for what is the final displacement produced. Okay. So therefore, S is equal to S1 plus S2 plus S3. See here, S1 refers to, here S1 is 30 into j cap, because here j cap is there, vertical direction. See, in the S2 is 20 into I cap. This is minus 30 into I cap, minus 30 into j cap. Now you please make substitution. S is equal to S1 is 30 into j cap, S2 20 into I cap, S3 is minus 30 into I cap, minus 30 into j cap. You please simplify this. Plus 30 minus 30 got cancelled. You are going to get minus 10 into I cap. Okay. See, therefore, resultant displacement is, therefore, resultant displacement is 10 meter towards west. So actually this means what? 10 into minus I cap. Minus I cap is directed towards west. Okay. See, therefore 10 meter along the west direction. See that what it implies. Let us take another problem. A motor boat is racing towards north at 25 km per hour, and water current means the speed of water current in that region is 10 km per hour, in the direction of 60 degree east of south, east of south. Then find the resultant velocity of the boat. You have to find out what is the resultant velocity of the boat. Okay. So this is east, north, south, west. The motor boat is racing towards north with a 25 km per hour. Water current east of south. See, water current is towards east of south. Okay. See, what is its direction? See, this is the water current. And 60 degree east of south. This is 60 degree. Right? And the boat is moving in the north direction. Velocity of the boat. This is velocity of water current. So now you please resolve this. So you just construct a parallelogram, and if this is 60, the angle between them is 120 degree. This angle is 120 degree. Now this is the resultant vector, resultant speed. Okay. See, what is the resultant here? VR is equal to, you just make use of the relation. We know that R is equal to root of P square plus Q square plus 2PQ cos theta. See, this is the case when two vectors are acting at a point. See, here I am taking two vectors. One is VB, another one VW. Here P is VB. How much is this? 25 km per hour. 25 km per hour. And Q is VW, velocity of water. This is how much? 10 km per hour. 10 km per hour. And R is taken as VR, resultant, that you have to find out. And theta 120 degree, which implies cos 120 is equal to minus half. Now you please substitute in this equation VR is equal to, say first let us take V square B, V square W, 2VB into VW cos 120. On substitution, V square B 25 square plus 10 square plus 2 into 25 into 10 into minus half. So you are going to get, this is 625 plus 100 minus 250. See, on simplification, so you are going to get 22 km per hour. See, this is 725 minus this 22. See, 22 km per hour. Please simplify this. So So you are going to get resultant speed of the boat is given by 22 kilometer per hour. And even you can find out what is the direction. Suppose if you take alpha is the angle made by the resultant, so then if alpha is the angle made by resultant VR with respect to VB, then alpha is equal to tan inverse of, so you just make use of the relation VB into sin 120 divided by VW into VB cos 120. You know the values, make a substitution. Tan inverse of VB is 25 sin 120 root 3 by 2. This is you remember sin 120 is equal to sin 180 minus 60 is equal to 0.8660 or root 3 by 2. So this is 0.8660. VB is 10, VW is 10, VB is 25, cos 120 minus 1 by 2. See, on simplification you are going to get tan inverse of 0.4330. So using trigonometric table, when you see the angle, it will be 23.4 degree. Alpha comes out to be this. See, therefore the resultant velocity makes an angle 23.4 degree with respect to the direction along which the boat is moving. See, therefore finally, see, this actually indicates in which direction the boat will move, because water is flowing in this direction, water current is in this direction, boat is moving northward, right? And due to that, boat finally started moving in this direction, and it is making an angle 23.4 degree with respect to the north. Okay, that's how we can calculate the magnitude and direction of the boat, resultant velocity of the boat. Okay. Rain is falling vertically. Rain is falling vertically with a speed of 35 meter per second. Wind starts blowing. After some time, with a speed of 12 meter per second, in east-west direction, east-west direction. In what direction? In which direction? Sorry. In which direction? In which direction? Should a boy waiting at a bus stop, hold his umbrella, Also find the resultant velocity of rain with respect to wind. See here, so you know that always raindrops fall towards south. See here, wind is blowing. See here, rain is coming down. Okay. See, this indicates the velocity of the rain. I just take it as VR. And wind is blowing from east to west. What is the rain speed? 35 meter per second. 35 meter per second. And wind is blowing with a speed of 12 meter per second. This is the wind speed, velocity of the wind. See, this is 12 meter per second, east to west direction. So therefore, naturally, the resultant vector acts in this direction. This represents the velocity of resultant vector. Let me take this angle as theta. See, this is the direction along which the boy should hold the umbrella. Okay, in this direction he has to hold the umbrella so that he can prevent himself from getting drained because of rain, right? So I just take this triangle O A B. Okay. What is tan theta? Tan theta is given by, tan theta is opposite side by adjacent side, AB divided by AB by OA. But you know that AB is equal to OC by OA. OC is 12, tan theta, this is 12, and OA is 35. So therefore, theta is equal to tan inverse of 12 by 35. Okay. On simplifying this, you are going to get tan inverse of 0.343. So using a trigonometric table, when you see the angle, it will be approximately 19 degree. See, therefore, the boy should hold the umbrella making an angle 90 degree with respect to the vertical. Vertical is this one, north-south direction. See, then only he can prevent himself from getting drained. See, this is, if this is theta, this is also theta, right? He must hold the umbrella making an angle 19 degree with respect to north, so that he can prevent himself from getting drained. And in the second part, they ask you to find out what is the resultant velocity. So resultant velocity in the second part, VR resultant. VR is given by square root of V square R plus V square W. See, because the angle between them is 90 degree, right? See, what is cos 90? Cos 90 is 0. See, if I want to VR in theta. See here theta dash is equal to 90 degree, which implies cos 90 is equal to 0. See, therefore entire term goes. See what you are left with, VR is equal to V square R. See, this is 35 square plus 12 square. Okay, you please simplify this. On simplification, you are going to get it is approximately 37 meter per second. See, therefore, because of the wind, though rain speed is 35 meter per second, because of the wind, the rain speed appears to be 37 meter per second, right? The resultant direction, along this direction, the rain speed is 37 meter per second. The position of a particle, is given by R is equal to 3 into 3t into I cap plus 2t square into j cap plus 5 into k cap, where t is in second, and coefficients have proper units, Then calculate velocity and acceleration of the particle, at t is equal to 1 second. Okay. So consider displacement is given by, position is given by 3t into I cap, 2t square into j cap plus 5 into k cap. See, if you want to find out velocity, you must differentiate this. Differentiating with respect to t. I am differentiating with respect to t. See, v is equal to dr by dt. This is equal to, you please remember the rule. Suppose if there is a function d by dt of t power n gives you n into t power n minus 1. This is the rule. You must remember. As per this rule, 3 t power 1 into t power 1 minus 1. Okay. into I cap plus 2 into t power is 2. 2 into t power 2 minus 1 into j cap. See here only constant is there. See therefore, say in the place of constant nearer to that I just take t power 0 into k cap. See therefore 5 into 0 into t power 0 minus 1 into k cap. Okay, like that. 0 multiplied by any number is 0. See therefore this gives you 3 into I cap. This is 4t into j cap plus 0. This is velocity. If they ask you to find out what is velocity at a time t is equal to 1, put t is equal to 1, you will get it. Okay, we will come to that later. See now 0 multiplied by any number 0, I just consider. Again differentiating. If I take this as equation 1, this is equation 2. Differentiating on differentiating. Equation 2 with respect to t, we get, see this symbol indicates with respect to. Okay, you must read like that. It's a chart form. See therefore acceleration is given by dv by dt, time rate of change of velocity. See this is equal to here constant, just like this case, right? Here also you will be getting 0. 4t on differentiation gives you 4 into j cap. See therefore what is acceleration? Acceleration is 4 into j cap. Therefore magnitude of acceleration is how much? 4 meter per second square. 4 meter per second square. If they ask you to find out velocity, consider equation 2. Say this is v is equal to 3 into I cap plus 4t into j cap. At t is equal to 1, they have given. So you are going to get v is equal to 3 into I cap plus 4 into j cap. You want to know what is velocity? Velocity magnitude is given by root of 3 square plus 4 square. See this is nothing but v square x plus v square y. So you are going to get, say 5 meter per second. See therefore velocity is given by 5 meter per second and acceleration is 4 meter per second square. If they ask you to find out the direction, then you can also find out direction is given by alpha is equal to tan inverse of Vy by Vx. Vy is 4, Vx is 3, then you can get the direction. Okay. Let us take another situation, similar such situation, how we can determine velocity and acceleration. A particle starts from origin at t is equal to 0 with a velocity of 5 into I cap meter per second and moves in xy plane under the action of a force, under the action of a force, under the action of a force which produces a constant acceleration of 3 into I cap plus 2 into j cap. What is the y coordinate of a particle? What is the y coordinate of the particle at an instant when its x coordinate is 84 meter. B. What is the speed of the particle at this time? What is the speed of the particle at this time? Okay, now let us find out what is the distance covered or displacement using this data, and later on we shall make calculation. See, consider the equation r is equal to ut plus half at square, ut plus half at square. See here, r is equal to initial velocity is given 5 into I cap into t plus half into a is 3 into I cap plus 2 into j cap into t square. Have you got my point? See, now you just make rearrangement. So you are going to get r is equal to 5 plus 5 into t, I cap. I am bringing I cap together. This is 1.5 into t square into I cap plus j cap t square into j, 2 by 2 is j into j cap. Have you got my point? I am arranging I cap on one side, j 2 by 2 is 1 into t square. Okay. See, this is of the form r is equal to x into I cap plus y into j cap. See, therefore x is equal to 5t plus 1.5 t square. They have given x component is 84, given x is equal to 84 meter. So therefore 84 is equal to, this implies 84 is equal to 5t plus 1.5 t square. It's a quadratic equation. You please simplify this. 1.5 t square plus 5t minus 84 is equal to 0. See, when you factorize this and when you make simplification, so you are going to get, on solving, you are going to get t is equal to 6 second, c is equal to 6 second. See, therefore, what is the y? Therefore, when you take y becomes equal to t square into j cap, t square. See, therefore, t square is 6 square, that is equal to 36 meter. They ask you to find out what is the y coordinate. Y coordinate is 36 meter. And also they ask you to find out what is the velocity. Let us come to question number B. They ask you to find out what is the velocity, and velocity is given by v is equal to dr by dt. dr by dt. You please differentiate this equation. So we are going to get v is equal to, see, 5 into I cap, say this one 5. Say when you differentiate t, you are going to get 1.5. When you differentiate t square, you are going to get 2t. 5 plus 1.5 into 2t into I cap plus 2t into j cap. You please rearrange this. V is equal to 5 plus 3t into I cap plus 2t into j cap. See, at t is equal to 6, at t is equal to 6 second, v is equal to 5 plus 3 into 6 into I cap plus 2 into 6 into j cap. This is 18 plus 5, 23 into I cap plus 12 into j cap. See, when you want to calculate what is the magnitude of this velocity, v is equal to, magnitude of v is given by 23 square v square x plus v square y, 12 square. See, on simplification, you are going to get approximately 26 meter per second. See, therefore, the velocity is given by 26 meter per second. I once again explain this. See, they have given at time t is equal to 0 means initial velocity. Initial velocity they have given 5 into I cap. And at that moment, what is the acceleration? Acceleration is given by 3 into I plus 2 into j cap. Now, I just bring coefficients with I cap one side. See, there is a 5 into t, 5t, half multiplied by 3 gives you 1.5, t square got multiplied, 1.5 t square into I cap one side. Then half into 2 gives you 1 into t square into j cap. See, this is in this form, x into I cap plus y into j cap. See, therefore, what is x? X is equal to this much, y is equal to this much. Now, I just consider x1. In the data they have given, x component is, x coordinate is 84 meter. Therefore, I put x is equal to 84. See, you just factorize this or solve this quadratic equation, you are going to get t is equal to 6 second. When you put t is equal to 6 second in the y coordinate, y is equal to t square, 6 square becomes equal to 36 meter. First part of the question is over. In the second part, they ask you to calculate what is the velocity of the particle at that time. At that time means at time t is equal to 6 second, what is the velocity of the particle? See, therefore, for this I consider this equation. I differentiate this equation as usual in the last class, last problem itself we have differentiated this. When you differentiate 5t for derivative of t, you will get 1. See, therefore, 5 For t square you will be getting 2t, 2 into 1.5 gives you 3, and for t square you are going to get 2t, right? So here actually 5 into 1, right? When you differentiate t you will get 1. See now 5 plus 3t into I cap plus 2t into j cap, put t is equal to 6, you are going to get 23 into I cap, 12 into j cap. When you want to find out what is the magnitude, this is of the form v is equal to vx into I cap plus vy into j cap. It is in a standard form. See, therefore magnitude is given by square root of v square x plus v square y. 23 square plus 12 square, you are going to get 26 meter per second. See, this is the velocity of the particle at that time, at a time t is equal to 6. So, knowing of all this, let us move on to another situation wherein rain is falling. Rain is falling. Rain is falling vertically with a speed of vertically with a speed of 35 meter per second. Speed of 10 meter per second, say 10 meter per second, sorry 10 kilometer per hour, 10 kilometer per hour. A man is going due east, towards east with a velocity 3 kilometer per hour. Find the angle at which he should hold his umbrella. So that he save himself from rain. He saved himself from rain. See here, rain is falling downwards. What is the speed? 10 kilometer per hour. 10 kilometer per hour. Man is going east. See, with a speed of velocity of the man 3 kilometer per hour. So I just take this in the opposite direction. Vm is equal to minus Vm, 3 kilometer per hour. Okay, and this is the direction of the resultant Vr. Let me take this angle as theta. As usual, theta. OAB this is C. Now tan theta is equal to, from right angle triangle OAB, tan theta is equal to AB by OB. AB is OC, OC by OB. OC is 3. Theta is equal to tan inverse of 3. This is 10. Tan inverse of 0.3. So when you see the table, you will be getting 16.7 degree. 16.7 degree theta. So therefore, he must hold the umbrella making an angle 16.7 degree with respect to north, so that he can prevent himself from getting drained. And if you want to calculate resultant velocity, so you can use this relation, VR is equal to root of V square m plus V square rain. So you please put these values. Velocity of the man is 3 square plus 10 square, see 109, see 109. Please find out, say you will be getting 10 point something kilometer per hour. See, that is the velocity of the resultant. Have you got it? Okay, let me stop at this stage. In the next class, we shall consider projectile motion of a projectile. Okay, thank you.